Hello, you are welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition. And in this lesson, we are going to learn the concept of sets. And we'll learn how to simplify sets. This lesson can be found in page 48. Now, what is set? Set in the simplest form, we'll say it's an irrational number. What it means is that a decimal cannot terminate or recur. For example, if I take square root of 3, the decimal of square root of 3 will be 1.73205080 and so on and so forth. It will never terminate, it will never recur or repeat. And so any number that does not terminate or repeat is called irrational number. And we are saying set is an irrational number because sets are numbers that are put under square root, which gives you non-terminating decimal or non-repeating decimal. So 4 root 5 is a set. Again, we are saying that in mathematics, any expression such as square root, cube root, or higher root, which cannot be written as a common fraction, is called sets. So root 2, cube root of 6, 2 root 3, root 7 plus 2, all these are considered as sets. So any number that goes under square root or cube root or higher root can be called set. That is if it cannot give you a simple answer. So in a nutshell, sets are root that does not have exact values or whole numbers. So look at root 6. It has no exact value or whole numbers. Look at root 43. Look at 2 root 3 and so on and so forth. But if I give you root 9, which will give you just 3, we'll come to that. If I give you root 16, which gives you just 4, this is not a set. This is not a set. But this is a set because this one, it won't give you exact value. This is a set because it won't give you exact value. All right, so we'll learn how to differentiate between numbers that gives you exact value that is not set and those that will not give you exact value. Now, look at this set, root of 18. We call this symbol, the symbol here, this symbol is called radical. The number that goes under it is called radicand. Okay, take note of that. So root 18 can be expressed to the lowest form, okay, as 3 root 2. We'll come to that. Root 26 cannot be expressed as lowest form. Root 48 can be expressed to the lowest form. 75 can be expressed to the lowest form. 74 cannot. So how do I know which set can go to the lowest form, which one cannot be expressed to the lowest form? We will understand this first by understanding perfect square. When we talk of perfect square, we are looking at if I have a number and I multiply that number by itself, the result is perfect square. Or a number that can be arranged in the form of a square, like 4. I can have 4 counters and arrange them 2 by 2, and that is square. I can have 9 counters and arrange them 3 by 3, and that is square. 16 can do that. But let's take 6. If I have 6 counters, can I arrange 6 counters in a square form? The answer is no, because if I go 3 by 3, it doesn't make square. If I do 2, 2, 2, 2, 2, 2, giving me 6, this will be rectangular. So 6 cannot be a perfect square. 7 cannot be a perfect square. 10 cannot be a perfect square. So perfect square can be 4, 6, 4, 9, 16, 25, 36, and so on and so forth. So in a simple form, we will say 1 squared is 1. 2 squared, that means 2 times 2 is 4. 3 times 3, 4 times 4, 5 times 5, 6 times 6. Let's do it up to 10. All these numbers you see here, the result of multiplying a number by itself is what we refer to as perfect squares. When these numbers goes under square root, they'll always give you exact value. And so root 9 is 3, root 16 is 4, root 25 is 5. That means you did 5 by 5, okay? That gave you the 25. So that is why we say root 25 is 5. Root 100 is 10. Root 81 is 9. Root 64 is 6. So you have to learn this and master it. Now, if you're able to master this, then you can now understand how we can simplify a set to the lowest form. All right, good. So you've seen all the perfect squares now, okay? So if I say what is root of 16, you know it's 4. What is root of 9? You know it's 3. What is root of 81? It's 9. What is root of or square root of 49 is 7, and so on and so forth. Okay, now 1 is a perfect square, but we don't use 1 in doing the calculations you are going to do right now. But 1 is a perfect square, okay, because root of 1 is this much 1. Now, how do we simplify the following sets to the lowest form? We'll ask questions, and the question we're going to ask, for example, the first one, which of the perfect squares that we've listed over here, these ones, which of them can divide 12 without a remainder, apart from 1? You know, 4 can divide. Okay, so if 4 can divide, then 4 can divide 12 as what? As 3. So we can write this as square root of 4 times square root of 3. Together will give us square root of 12. And because 4 is a perfect square, it will give us just 2. And 2 times root 3 is the same as saying 2 root 3. That's how we write it, 2 root 3. If you take 18, which perfect square can divide 18? Can 4 divide 18? No. 9, yes. So 9 can divide 18, which means I'm going to say root of 9 times what will give us 18? That will be 9 times 2. So if it is 9 times 2, and because 9 is a perfect square, it will give us 3 root 2, and that becomes our answer. I hope it makes sense. Good. What about 28? What perfect square can divide 28? Starting with the lowest perfect square, apart from 1, is 4. Can 4 divide 28? Yes. And that will give us 4 times what will give us 28? That is 7. And each of them will be under square root. But because 4 is a perfect square, it will give us 2 root 7. Let's say the last one, root 45. Which of the perfect square can divide 45? Can 4 do it? No. The next one is 9. Yes, 9 can divide. So I'm going to have root of 9 times what will give us 45. And that is 5. So root 9 we say is 3. So 3 root 5. Good. So you see that anytime they give you a number under square root and they want you to reduce it to the lowest form, ask yourself which of the perfect squares that we've listed here can divide that number without a remainder. If none of this perfect square, apart from 1, if none of this perfect square cannot divide that number, then it means that number cannot be reduced. For example, if I say what is square root of 26? 26 is an even number. 2 can divide 26. Yes, we agree. But 2 is not a perfect square. 4 cannot divide. 9 cannot divide. 16 cannot divide. 25 cannot divide. 36 cannot divide. I've said it. And so this will be remaining. It will be the same as 26. So root 26 is the same as root 20. Nothing can be done to reduce it to the lowest form. I hope it makes sense. If I say the number, let's say 42. Okay. 42, you know that 42 is a number that has a lot of factors. But none of the perfect square can divide 42. If you take off 4, 4 cannot divide. 9 cannot divide. 16 cannot divide. 25 cannot divide. 3 can divide 42. 14 can divide 42. 2 can divide 42. But none of these numbers, none of them is perfect square. And for that matter, this root 42 will still remain root 42 without going to any further reduction. I mean, you can't reduce it to any simplest form. And so that becomes your answer. So this is how we reduce sets to the lowest form. I'm sure this has really helped you. Thanks so much for watching.